All right,
Thank you very much for joining us today for 20th Meetup of K8SUG Singapore. We are very much excited to host you guys every month, and this would be the 28th meetup. We are growing globally. If you can see, we have 2,900 members. Meetups we started in Singapore, K8SUG Singapore. Then we expanded in Australia. We started in Australia, and then now we went into Canada, UK, and now in Australia again we have Melbourne and Sydney, two places where we are going. And soon we would also be going around the APAC region as well. So if you give it, how you know if someone who is ready to volunteer from Thailand, Indonesia, somewhere, just ask them to reach out to me so we can work it out something. So today's topic. So today's topic we have two speakers. So usually Thijs Feryn was supposed to give the first session, was he would like to go second. So Siva would be talking about deploy and manage container application with Azure Kubernetes services, and our second special speaker would be Thijs Feryn, who is a technical evangelist at Varnish Software, who will be talking about accelerating Kubernetes cluster with Varnish caching. Our main sponsors today are Core Cloud, Microsoft. This auto presentation. So yeah, main sponsors Core Cloud, Microsoft, and event sponsor is Varnish Software. And as you guys know, from last couple of meetups, what we are doing, we are running the quiz all the time. But from last couple of meetups, since we have a tie-up and sponsorship from Core Cloud, so the first two winners of the quiz get 6 months subscription from the Core Cloud. Meta team, the K8SUG Singapore, Yongkang again. I think I have to hold it. So Yongkang, he is our founder, and then me and Fazil, we helped him to grow K8SUG Singapore in Singapore, and then we also together helped expand it globally as well. So that's where we are now. So Fazil and myself, we have a dynamic team here. Ram, Siva has been promoted as a lead volunteer for Singapore, and and we have Fatima. So Fatima helps us. So please stop. Uh, so Siva, Rama, and Fatima they help us. Fatima helps us mostly with our LinkedIn posts and all those things which are done in the background. So that contribution also counts a lot. For K8SUG Singapore, we are always looking for speaker, volunteer, and sponsors. So if you guys, anybody who want to speak for the community, please scan the QR code and register your topics. We will reach out to you and give you a slot in upcoming meetups. If anybody of you who wants to join this dynamic team as a volunteer, please scan the QR code and register yourself, or you can come and reach out to me, meet me, and share your number. We will add you to the volunteer groups. Sponsor, if you know anybody, anyone who is willing to sponsor us, happy to get the help as much as we can. So these two slides we introduced today, the Cube Astronaut program, and the reason being, since we are CNCF Kubernetes or Meetup, the Astronaut program is something which I have started this year. So if anybody of you who has done all these certification of Kubernetes, like CKA, CKS, and CKA application developer. So there are like four. If you have done it, then you are eligible to have a Cube Astronaut title, and you can reach out to us or to CNCF directly. Also, for us K8SUG member, we have some promo code running. You can take a screenshot or photo of it. So if you are a pro user, you can use this code K8SUG KK for Core Cloud, and 40% off for business. Yes, it's okay. And if you can say at the end, there is May 24 special K8. This is for the member who would want to go for Q astronaut. And with that, I would like to call Siva on the stage, our first speaker. Siva, over to you. Give a round of applause to Siva.
Yeah, hi. Good evening, everyone. Do you need mic or without mic is okay?
The mic,
Mic is that. Okay. Okay, yeah. So thanks for joining this evening. Yeah, so I'm trying to share some about kind of a basic how the application container application can deploy AKS and how it is different from a Kubernetes which we manage at our process and then how about AKS. So yeah, mainly yeah, I'm Shiva, being working as a kind of cloud and containerization and then some automation platform for past few years, and then overall as a infra lead. Okay, and yeah, so the topic is about deploy container applications with the AKS. We have different, I can say, Kubernetes platform. Each cloud manages its own tool. So when it comes to the Microsoft Azure, is Azure Kubernetes services. And yeah, so yeah, there is quick agenda, some kind of overview of AKS, and then overview of Azure Container Registry, and overview of some Docker container and kind of deployment, which is a basic application deployment component, resource I can say, and service and various type of services, and then English, and then followed by a quick demo. So we have limited time. I may not spend more time to theoretically to cover. I'll just go through demo, kind of creating a cluster and then deploying application and then access it from the outside since we have limited time. Okay. Yeah, so overview of Kubernetes. It's kind of managed Kubernetes services that you can deploy and manage applications. And it is mainly the major advantage of having a cluster on Kubernetes in a cloud, which may be Azure. So the cloud vendor will take care of most of the operational tasks where you can manage on your application workloads instead of spending your time to manage the base cluster and its components. Okay, so that is, yeah, again, this can be run in either on premises as well as cloud. On premises, there are one of the two like maybe Rancher or Minikube. There are various, right? And having a cluster, yeah, it's mainly scalability when you are using especially in the cloud, scalability when there is a workloads or going beyond workloads are scaling, then it will automatically increase the number of pods as well as it also automatically increase the number of nodes when the resource uh, or or effectively utilizing or maybe consuming more resources and require to add on additional resources. So the nodes will automatically add on in the cluster as well. When it comes to the high availability, yeah, the application, yeah, the cluster can deploy when it comes to the cloud. It has multi availability zone within each region. So the node pools can be created in having each node, maybe yeah, nodes can balance in multiple availability zones within the region when you create a new node pool. So such a way that it will available at any time, even number of pods as well. When the application is deployed, it can the pods can deploy in multiple nodes across available zones. So such a way that when one zone goes down, the system node and the application will still remain available. Okay, so kind of resource isolation again. When deploying applications, you can use one cluster for hosting multiple applications and define one application, maybe I can say namespace for each to host each application, and the namespace can define with resource limits like a quota or CPU memory, so that when a cluster is sharing with multiple teams for multiple applications, application A may not consume overutilize the resources and then end up with the application B kind of having a low resources when their application is uh, kind of workloads are growing. So resource explosion, and again when we create the namespaces or application A cannot communicate, I can say cannot or maybe team will not have access to or visibility to the namespace, maybe application B which is hosted in the namespace, different namespace. And comes to the load balancing, so uh, when there are when their application is deployed and then number of users are accessing across maybe globally or multiple users when they're accessing, then it will automatically uh, even increase the number of pods as well as access the application among the available nodes. So that is some of the benefits having a cluster. And then when it comes to the some of the architecture, the AKS has most of the clusters here. Right? It comes with a control plane, master nodes, and then data plane, worker nodes. So as I mentioned, control plane will managed by a vendor who is Azure here. You don't need to take care of any kind of any operational overhead within the control plane. It has some of the components like API server, scheduler, controller manager, etc. Kind of API manager, it takes care of all the API resources and management. And then scheduler will take care of when there is any deployment or schedule. It will take care of identify what are the nodes has available resources. Then accordingly it will schedule the deployments in the where node has enough amount of resources. And control manager, so when it comes to the kind of replication, all replication or maybe deployments or whatever, all these things will take care by controller manager. And then it's one of the database which contains key and value in the form of key and value, and maintain the cluster desired state. If anything goes wrong, still can restore it from the ECD database. And then data plane worker node components like kubelet, kubeproxy, and container type. So these are available across all the nodes in the node pools.
Siva, one quick question.
Yeah.
I believe Microsoft here in Singapore has two availability zones.
Okay, I think there are three. Yes. Yeah.
So in order to get the full benefit, you actually have to deploy in all three zones.
It doesn't mean you need to deploy a resource across all available zones. To maximum benefit, yes, it is recommended, but you can go for one plus, I can say more than one zone to have.
If it's two zones, and if your primary zone goes down, you're down anyway.
Doesn't mean
That's
you
it.
need to enable multi-available zone when you are creating a cluster, so that when you deploy a node pool, and it will equally deploy a nodes in each available zone, so that in one zone failure, still the other zone
But if you have three controllers and two controllers go down, your cluster is dead.
Uh, controllers. So even when you are deploying a cluster, a system code, you still choose multi-AC. When you are, there is an options hyphen zones.
Yeah.
And zone 1 and zone 2, maybe zone 3 if you are limited to zone 2. Still, if one zone is closed down, the cluster will be accessible from other zone. Doesn't matter.
No, I'm just asking. So control plane is managed by Azure, right?
Azure, yeah.
That's not under our control. If it's multi-AZ, single AZ, whatever. So it's all managed by Microsoft. So it's
But still, if you don't,
yeah, obviously they will gonna put in multi-zone, but as they said, if two zone goes away, so yeah, that's gonna be down for sure.
yeah, if two zones, then
Yeah,
yes.
because actually cluster needed quorum will be gone, and it's all done.
Okay.
Thanks for adding. Okay, so yeah, and then overview of Azure Container Registry. Yeah, it's kind of it. Yeah, so to deploy an application, we need an image, and to store an image, either you can get it from public repository, which is a Docker hub, or most of the enterprise organizations do it when you're hosting in a cluster in Azure or AWS or Google, wherever. Prefer to recommended to have a private repository when it comes to the Azure, which is a Azure Container Registry. It's all about to store the images and then push your own managers and images, and also keep it secure from accessing to the public. And a Docker container, yeah. So this is one of the major component when it comes to the microservices, right? So the Docker, yeah, it's kind of lightweight fact, and comes with the yeah, it's kind of lightweight image and share with the kernel of the operating system, and then on top of it, yeah. So the Docker file, it's kind of simple execution steps where the image is comes from, and then current working directory and copy when the booter copy what are the components or files to be, and the where required when the and expose the application with the x whatever port number, right, and then run the command when it's booted. Some of the simple steps, combination of simple steps uh, preparing as a container.
Actually, expose does not do anything.
Oh yeah, so oh correct, yeah. So we still need a service to be created, and then
I mean, when you create an image out of the file,
okay,
if the image, if the container runs out, whatever code that you have coded, let's say you have Node.js, you have coded 5050 code, that will still run. Expose was the legacy thing. It's still continuing. This is put for documentation, because if you put into a Docker file and you put into a Docker Hub and you see the layers of a Docker in the Docker Hub, the expose just tells you that it's a documentation. It's no longer functionally usable.
okay, thank you. And yeah, some of the Docker architecture like yeah, build the container and then pull and then run the container. So some of these, yeah. Uh, so when it comes to the deployment, so yeah, deployment is kind of one of the primary resource to deploy an application. And deployment can have multiple, I can say, components and the number of replica sets as per application requirement. And yeah, to manage availability and connectivity to the application, yeah, we can have an application and deploy that a kind of resource deployment. And it required a manifest file, a combination of all these kind of which container and what would the namespace and what would the application name. So these are the basic things to prepare a manifest and then deploy using kubectl. And service, so yes, as I mentioned, export is just a legacy word. So to access the application when it is deployed in the cluster, we have a kind of a resource which is a service. And the service again, yeah, Kubernetes service are used to logically group of pods and provide network connectivity, right? It's allowing direct access to them through the specific IP address or a DNS view. And yeah, there are different types of services: load balancer, node port, and then cluster IP. So cluster IP to access within the cluster. When you use the resource type with cluster IP, the application can access within the cluster. It will not access the outer of the cluster. And node port, yes, it can access, but with the node port and then node port, node IP, and node IP, and then followed by node port. Yeah. And then load balancer, it is one of the component which you can expose service type with load balancer and then access application out of the cluster. But again, this load balancer can only enable maybe with one application. So there are different type of load balance, like maybe if you go to Ingress, so yeah, we have some slide as well. Okay, so yeah, this one again to add on one of the important. So the load balancer works on the HTTP layer, which is a layer 4. Okay, and again, we cannot access or route multiple applications via this maybe Azure load balancer. But when it comes to the ingress, yeah, you can configure to route, or maybe route-based IP, route-based, or maybe you can access to configure multiple applications to access. And again, it operates on the layer 7. And it's mainly for access HTTPS and TLS, and then yeah, TLS services. Okay, so maybe quick demo.
That I have a question.
Yes, please.
I haven't used Azure, don't throw anyone in front. So yeah, so doesn't it have the application load balancer?
It has application load balancer.
So that work on L7, right? And that we can use as a service in the
That application
in
load,
the EKS, right?
yes, you can still use add-on application load balancer.
But that work on L7, right?
I
So-
remember it
so
is
the way-
L4.
So so within the cluster is level 4, right? Level 3 and 4 and all. Outside when you connect it, so you have Azure or any other cloud provider provides a load balancer, which is balancing between your nodes, right? And this load balancer that you're talking about, that you just show about it, right? This is like a facade for the pods that are running. So pods are separate these services that when you say load balancer, they utilize this cloud load balancer and publish the external IP, the node IP out. So this is what the node balancer can copy upon. What comes for ingress can directly control it. It doesn't require a load balancer. Just need a cluster IP and then go.
Ingress controller also need something to enter, right? How I know, like you are running ingress.
That's an external load balancer.
Yeah, that still there is a load balancer there, right?
Yes, but that load balancer and this service load balancer is just a terminology. The reason is the moment you define the service load balancer, you should have an external load balancer which supplies you an IP so that it will associate this service with an IP. Otherwise, if you just define a load balancer, you can deploy an on-prem. If you don't have a load balancer, you define a service, it will say pending for the external IP. So it is just a specification. It is not a load balancer under the terminology. When you say service is a load balancer, it is not load balancing. It's a terminology to utilize a load balancer for an IP.
Service will backend have simply attached to the whatever tags that you specified, those pods. It will divert like within the cluster. It will make sure that
That's inside the cluster.
cluster.
But from outside, if you want to do that, when you define the service as a load balancer, you technically don't even need ingress. When you define a load balancer, if you have a load balancer that is the cloud provider, it will fetch that, it will get an IP for it.
That's what I'm saying. So if we go back a bit, right? The era where there is a VM or and all, right? So on one VM you assign something, there is a load balancer which is basically routing traffic. Right? Similarly, here all the things have been done by the controller, right?
Correct.
So when you create a service, its type is load balancer, and with annotation you can say that it's application load balancer or network
Yes.
load balancer or classic whatever, right? So if I mention application load balancer, right? So doesn't it gonna do the L7 part? The question is that. I don't think so. Sure.
Yeah, the idea that if you specify, I don't know if you specify application balancer or this thing, what happens as an annotation out, especially on Azure. But typically what generally happens is when you define a load balancer, you have basically
a very
connect
short
to a load
code.
balancer and assign your IP.
Okay, thank you, Manju, for adding. Okay, so let's go through quick demo. Maybe we can sort out your questions.
No.
Okay, thank you.
CLI for the win.
Okay, yeah, I am following Azure CLI. I have.
Could you move the StreamYard thing?
Yeah.
Yeah. Maybe move the top right or whatever.
Okay.
Okay, that's good. That's good.
Is this okay?
Yeah.
Okay. So I have a subscription which I set it as a default, and then followed by to create a cluster we require there is a primary component which is a resource group to create.
You're creating the cluster of the flights.
Oh yeah. I just created in the past. I thought my session will be second time, the second session. So in between, I thought to prepare again. But yeah. So this is I created a resource group, and before after resource group, yeah, to have some just to quick demo. Not sure we may use this container registry, but this is the way to create a container registry like. Azure ACR create followed by within the resource group, and then name of the container registry, and then followed by SKU size. There are basic, standard, and then primary. Okay, so again, I am just trying to push uh, an image to the container registry which is created.
Where is this image building? On your local computer?
Yes, yeah,
or
it is. If you look at here,
it's building on your laptop or in the
yes,
cloud?
yeah. It is building. I have an image pulling from the public repository and then pushing into the Azure Container Registry, which we have created. Yeah, if you look at here, maybe. Yeah, it is still.
Yeah, so it's doing a Docker build behind the
Correct,
scenes.
yeah.
Pulling the image from HDR into your cluster using AKS. Is there any cost for pulling or let's say if you have the image that like here then like you upload to the US registry and then you pull it to the APAC cluster, is there any cost?
It depends on the usage. And again, the cost will be whatever image is posting in the. It's kind of one a storage component. So within cluster or within the cloud, I don't think there will be any charges. If you are pulling or pushing images from public to Azure, like there is I hope there will be a this cost will be more
Cross region then charges.
charges, yeah.
Cross
So normally we prefer to have a registry within the same region to avoid these charges and then latency issues as well. Okay, so that is one image pushed into the ACR. Yeah, so to just list out what are all available, Azure ACR repository list. Yeah, this is one we have deployed and then it is available. And then maybe I'll go through creating the cluster. Okay, So since we have limited time, yeah, if you look at here, command line, Azure ATS create resource group which we have created some time back, and then these are all the variables I have defined, and then node count. So the one this is the one we were referring, number of node count within the system pool, and also there is another option to add a hyphen Jones, and then followed by number zone 1 2. If you want multi available, then you can define all available zones 1 2 3. So if you need to, just provide hyphen zones followed by 1 and then the system pool will have a nodes in both available zones.
So controller redundancy is Azure's problem. Okay.
So and again, generate SSH keys when it comes to for system pool. Yeah, when it comes to if you want to log in, then have a SSH key. Generating SSH key is recommended, or create your own SSH key and then authenticate.
This is for using kubectl from your local to prompt to the control node.
And then the node VM size, the SKU size. There are available. There are multiple node sizes available. SKU sizes. It depends on your requirement. Okay. And then network plugin, I'll go with Azure. Default, it would be a Kubernetes, but I'll go with Azure.
Sorry, see, but the SSH keys is to log into the node.
Nodes.
Use
Nodes, yeah.
so the
Sorry.
node login.
Node
not,
login,
Not,
yeah.
not a kubectl login. Authentication.
Yeah.
So you pay for the nodes and you pay for the controller as well.
Normally, for control plane nodes in Azure, we don't need to pay. There is no charges until unless you choose maybe high available, maybe high compute resource instance size. That is what I understand. You don't need to pay if you choose a maybe free instance as a SKU size. Yeah. Because that is managed by you only pay for worker node instances or capacity.
AWS, you need to pay for control plane. There's a standard cost.
Okay.
You pay for
So in gas is quite popular product, the price.
yeah, but you see the node cost so much not higher.
Not highly, but
But yeah, when you're running maybe thousands of pods, but you cannot go with the free tier SKU size. You definitely need to choose the custom size and then maybe yeah, there will be a charge.
first in on-prem, can you use the same command, or you could use another setup?
Okay, so until unless you are using an Azure stack, use the same commands. If you are deploying your own maybe different vendor or different maybe Minikube or Ratchet, Azure CLI may not work. But Kubernetes works for all the clusters. It doesn't matter whether it is in cloud or it is in. There are other tools as well. There are other tools like Terraform is widely used tool for cluster automation. And even you can use PowerShell or there are many tools.
It's almost standard.
Yeah.
mean like the virtual plans still with things like smart frame or the Microsoft Entra. And can I still access the Azure UI to manage or like monitor Microsoft?
Okay, so you need to integrate with Azure, and there is a pack called Azure Stack, if I remember. So that maybe Azure will provide all the control plane resources still, but maybe the infra, I think, yeah, still we will get an infra from Azure, but it is kind of hosting on your own on premises. It is not exposed to the other, I can say, partners or anyone. Kind of private, maybe a hybrid, I can say. Okay, it is.
Cannot be found in subscription.
Yeah,
Well,
maybe I will just remove this one. Okay, yeah, looks like it is already created. Let me quickly check. Yeah, so we have a cluster. Let me quickly deploy a simple application. And then once cluster is deployed, yeah, this is the one to authenticate the cluster with the within the subscription.
right, a few config changes.
Okay, so now we have cluster
Bad boy, you're running.
authenticated. We could see there are two nodes which we have defined while creating the cluster, and then so yeah, these are the components control plane what we discussed, and then core DNS, and these are the basic components which which deploy part of the cluster. And then since we don't have a node pools, maybe I'll quickly go ahead and deploy a simple application.
Repetitive. Quite fast. The service come up soon.
Yeah, as you mentioned, when we deploy a service, it comes with there are types: load, node port, cluster IP, and then load balancer. So the load balancer is defined for storefront, which is exposed to the outside of the cluster. Yeah. So this is how to deploy a simple container application within the AKS. Any questions? Okay. Thank you. Thank you very much.
Thank you, Siva. Thank you. That was really good one, the quick stuff about AKS. And I would like to move on to our next guest, Thijs from Varnish. And I will hand over to Thijs.
Yeah, just give me a second, right? Can I have the plug mic?
Okay.
I'm imagining durian plantations. But never mind.
I think your studio is still sharing. You
Almost there.
Stop sharing.
This is more tea than durian.
This is my standard background, I guess. Should change it one day.
That's nice.
Comes with the Mac updates. What the hell were you even talking about, right? Background.
Relaxing background. No solar panels inside.
Almost there.
I think. Okay.
Are we good? I have a different keyboard layout than what you're used to. That's okay.
Yeah, the Z and the A.
I have the Azure. I have the Azure
keyboard.
Yeah, I know.
Okay.
So anyway, let's give me a little bit of context, right? So I don't live in Singapore. I love coming to Singapore. If you need help, just let me know, or do I just keep?
Yeah, I think.
Should I share the screen?
Which screen is being shared? 1 minute.
I want to have this one, right?
Wait. The stream is.
So this is my third time in Singapore. I live in Belgium. The name of the game today.
The screen on that screen. I think you have mirrored it.
I haven't mirrored
You
it
haven't mirrored it.
deliberately, so you need that one. All right, let's give it a go. I'm going to switch.
You have to move your slide over
Yeah,
there.
let's try it. See what happens.
Good, yeah.
Am I good?
Excellent.
Wonderful. I like having a presenter screen for two reasons. I can see what the next slide is, and I can see how I'm doing on timing. Because I was allocated 30 minutes, right?
Yeah, 35.
35. The luxury. The luxury. All right, let's see how this works. So I first need to make sure this Bluetooth thing it buzzes. We're connected. So before I can get started, we need to do a crowd check. We need to sure that we're on the same page, because what's the purpose of me continuing if we're not in agreement? So I've done this a lot. This is my 337th presentation, I guess. So I do this through three distinct statements. I will present a statement, three of them, and you will tell me whether you agree or not. You can agree in a very polite and simple way by raising your hand. But since we're in a friendly environment, you can scream, shout, do whatever you want. If you don't want to participate, that's fine. It's a safe, friendly environment. So let's do it. So, dear friends here in Singapore, are we ready for this?
Yes.
Are we really, really ready for this? Because I came a long way. I want to make this fun, right? So, statement number one. Ladies and gentlemen, here at Microsoft Singapore, do we agree that slow websites suck?
Yes.
Wonderful. Great audience. See, that always works. That always gives me a little bit of the temperature and the barometer of the room. So we agree on the fact that slow websites suck. Second of all, do we agree that slow websites are an essential, or web performance is an essential part of the user experience?
Yes.
So if user experience is bad, people will go somewhere else. There's plenty of competition out there. Here's the third one, which in my opinion is slightly more controversial. Based on prior experience, the answer is usually quite meh. Do we agree that slow websites are just as bad as websites that are down?
Yes.
Yes, yeah, no, yes, no,
No.
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 The answer C is meh. But regardless of your opinion, here's the reality, which does not care about your opinion. If your website is slow or your website is down, you will lose money.
That's true.
You will lose space. Might even lose a little bit of Google PageRank. So, okay, we've been in that situation. How do we get out of it? So if your website is slow, a lot of people will say, well, if it's slow, it's probably a capacity problem. So we need to add capacity, right? That's looking at what's right ahead of you. It's symptomatic behavior. It doesn't really tackle things in the long run. But fair play, if the house is on fire, you need to do some firefighting. So in the short-term run, throwing servers at a problem is not really the issue. But in the long run, you're just throwing money at the problem. It's not really sustainable. And as the famous poet, Notorious B.I.G., once said, more money, more servers, more problems. So we really don't want to get into that. So that strategy, discredited in the long run. We have other strategies. If your website is slow, why don't you identify the slowest parts and optimize it? Top down. Your network, your data center, probably don't want to touch that, but you can do it. You can optimize it there. Your infrastructure, your operating system, your runtime stack, maybe also your application code that you write, maybe have a look at that. Yeah, everything, even the HTML, JavaScript, you name it. All fun and games, and it will get you the gains you need. It's a very sensible strategy. But after a while, you'll hit those limits, point of diminishing returns, where all the money you invest in it will only yield a certain gain in the beginning, but in the end, it would taper off. So luckily, I came here with a third. I came here bearing gifts. Well, you saw our colleagues bear gifts. But the solution, in my opinion, it's not really an objective opinion. It's quite subjective. Is why don't we use caching? And I love using the metaphor of boxes, because caching is nothing more than storing pre-computed results in boxes for later use. And I always use the following if people are in doubt. Like when I ask you, what's 2 plus 2 is? That was quick. Did you compute that?
No, look up David.
It came here. It was in the cache, right? It was in the cache. Now we're going to talk about caching today, but we're going to do it from a Kubernetes point of view because this is the Kubernetes Meetup group. I'm actually quite happy to be able to do this here. I've been meaning to speak at Kubernetes groups for a long time, and I was waiting for something to be released at our ends that would make it worth our while. And that happened, and I'll talk about that. But that being said, first I'd like to say hello. My name is Thijs. That's how you pronounce that. It's I'm a Dutch-speaking Belgian, so I have had a 12-hour flight to come here, but your country is absolutely... Well, your country, who's local here? Let's start with that. Who's local? Who's not local? Well, can we agree that it's a nice country and it's great here and life is good? It's hot.
Yeah.
I had a guy said me, oh, you've been familiarized with the weather, hot, hot, or hot. So yeah, that's it, but I'm very grateful to be here. I'm the tech evangelist at a company called Varnish Software. Now, by show of hands, who's heard of Varnish Software before? Good. Most people that know us because of our open source project, which is part of the business we do. We're stewards of this open source project that is used by about 10 million active websites, representing 22% of the top 10,000. And this is irrelevant in this cloud native context is our official Docker image, which is open source, has been downloaded more than 10 million times. Of course, that's only part of the reason why we're here. We're also at Broadcast Asia. We need to sell stuff, make some money. People need to get paid. So we also have an enterprise offering that came out of open source. The open source has been there since 2005. I've started working with open source in 2010. Been a strong advocate of it. But after a while, we noticed that people needed a holding hand, a helping hand. They needed support. So we started this Varnish Software entity out of a consultancy company to initially provide support. But later on, as we went forward, we noticed that there was need for specific features that weren't in open source. And that's how we came here. Starting off in web acceleration and then moving into the world of private CDN and edge compute. That's the world we live in. And if I were to define what we do, I'd say we're a company that builds software-defined, strong emphasis on that, web acceleration, and content delivery solutions. And yes, we're at Broadcast Asia. Who's here for any of the tech events at, what is it? What's the official name of the group? ETX. Yeah, so anyone there, stop by our booth. It's in Hall 6, G37. Do we have free drinks? Huh?
No, but
we ran
have a
out.
lot of beer.
We still have a lot of beer, so if you're into drinks and more goodies, please stop by. Now, personally, I'm the author of a couple of books. Getting started with Varnish Cache, which was my first one. I wrote with O'Reilly many years ago. But I'm happy. Well, it wasn't, but the context wasn't really happy. I wrote a new book during COVID lockdowns. COVID lockdowns were long, so it was a big book. But why is this relevant? Because I have two 2 copies. I won't leave them here because the camera is recording me, so people wouldn't be able to see. But in the end, I'll raffle a couple of copies. Now, before we get really to the meat of this thing, let's get philosophical about caching. Why shouldn't you cache? Like if you load, maybe from a Kubernetes or non-Kubernetes point of view, if you have this service, why would you recompute the data on every request if the output doesn't change? Why go to the web server? Why go to the application runtime, bootstrap all that code, connect to that database, call that external service? And the output you're generating for that page is the same every single time. Why do that? That's the philosophical aspect of it. And there's many layers of caching. Even your operating system does caching under the hood. Caching I'll be talking about is HTTP caching. All right, normal interaction patterns when you talk to a system. A user tends to connect directly to a server, which is fine. Most of us operate in that way. However, we're also, over the years, as systems has grown more popular, been made aware of the dangers of exposing our servers directly to the end user. Growth and increase, a spike, if you will, of users will obviously have an impact, but also the type of workload that we're loading, right? If it's quite compute intensive, your server may catch fire is maybe excessive, but it will get in trouble. And that's where our service comes in. Now, it applies both to open source and enterprise. For the sake of this meetup, I will mostly be focusing on open source because it allows you to test it yourself and get acquainted with software that's quite powerful. So we position ourselves as a so-called reverse caching proxy, meaning that we're in between the user and the server, mostly closer to the user, to ensure that every request we get, we handle it, and if we can serve it from the cache, we do. And in that way, we offload all of the pressure from the server. That's why there's a dotted line at the server. We try to reduce communication. So we either talk to the server because content is not yet cached, content has expired, or content can never be cached. That's the name of the game. And we operate on something, and I'll throw in a buzzword because buzzwords tend to be nice. We operate on the edge. The edge meaning the outer tier of your web platform. That's where we operate. And there's cache control headers out there used by HTTP to set the duration of the cache. So any takers here, how long will this be cached? 500 seconds, straightforward, right? What will happen here?
Not stored.
Yeah, it won't be stored in cache. But let's try. There's people with opinions here. Let's figure this out. What does private mean? Any takers? I'll give it 3 more seconds, then I'll answer the question. Private means one. Come again? No, private means it can only be cached privately, which means by a client. So your browser is allowed to cache it because remember, these headers were invented for browsers initially. So private means a shared cache, like what we do, can't cache it. Here's an interesting one. What does no cache mean?
It can be cached, but I think there's something to do with invalidation.
Yeah, you know the trick here, right? So no cache doesn't mean you can't cache it. No cache means you cannot serve it from the cache without revalidating whether it's fresh. It doesn't mean the same. The fact that you can't cache it means no store.
Yes.
You know that proverb, there's only 2 hard things in IT, like naming things and caching validation. See, we have good people here. So that's that. They were invented for browsers, so you can use them in all the major browsers. But we know the limitations of that, right? If I do Command R or if you do Control F5, you're just flushing those caches. Yep. In your developer tools, you can disable cache. So what's the purpose? And even if you leverage the cache, it's a cache entirely private for you, for that resource. So it means if you're visiting 10 assets, JavaScript, CSS, images, those are all separate. So it doesn't really conserve any resources. But luckily, we adhere to all those standards as well. Not because we're so cool, but because it's expected. There's cache control headers. A lot of them are made for shared devices like us. We adhere to them. So that cache control header, we respect it. And we can forward it. And there's variations in it. Now, I can talk for hours and hours, and a couple of weeks, I'm going to Poland to speak about cache control headers, like 1 hour of cache control headers. I'm not going to do that now. What I'm going to say is cache control headers get you a long way, but only so far. After a while, you'll hit the limits. And then you need to customize things. And that's where our built-in programming language comes in. It's called the Varnish configuration language. We call it VCL, pretty much. It's a domain-specific language that has certain capabilities. It can specifically built for caching. It only works within Varnish. It has a curly braces style. It is transpiled into C at runtime, compiled to machine code, super fast. but it's built for request handling and routing, response manipulation, selecting which backend you're connecting to, controlling every aspect of the cache, where to cache it, how long, how to revalidate, all those aspects. And also, that's why edge is relevant, also decision-making on the edge. You have a language which you can intercept everything from request to response and manipulate it and tailor it to your exact needs. I fell in love with Varnish because of VCL. I was working in a hosting company. I've worked there for 15 years back in the day, and we needed, silver bullets don't exist, but we needed something that came pretty damn close. And the open source Varnish, a version of Varnish got me hooked. And VCL allowed me to bypass some of the lack of discipline that developers have sometimes in terms of how to use cookies, how to use headers, all that kind of jazz. It's not a top-down programming language that you use to define all the behavior. There is a standard behavior that has different aspects, different flows. This is a finite state machine. This is our finite state machine. And every little box has a name, and that's a state. So if you look at VCL receive, that's the starting point. You receive a request. And then when it's cacheable, or not cacheable, or whatever, we create a hash. So we use the URL, the host header, create a hash, look it up in the cache. If it's a hit, then we deliver it straight to the user. That's the green path. If it's a miss, that's the blue path. Well, then we need to connect to the backend, which we try to do as limited as possible. So we set up the fetch. You can intercept that, you can change things, and then you get the response, and then you serve it. That's pretty much how it works. Here's a pretty simple piece of VCL, simple as it gets. Fact of the matter is it's an extract from a WordPress template that we have. And it says in WordPress, there's an admin set of admin pages. So if we hook into VCL request or VCL receive, and the request URL matches, that's what the tilde does, a regular expression with /admin or a subordinate resource, well, then we don't really want to cache because it's highly personalized and there's sensitive data in there. So we say return path, which if we look at this, gets us the red path. And the red path means never cache. Blue path, like a cache miss, isn't the worst thing in the world. A cache miss is a hit that hasn't happened yet. A bypass is slightly worse, but it's desired behavior. And under all other circumstances, we're going to strip off all the cookies because the cookies have a level of personalization and we bypass the cache. So this is just an example. This is not a VCL talk. This is just me allowing you to dip your toes into the wonderful world of VCL and explore it, see what it's about. You can do more. Oh, I forgot to say, there's a version marker in there. It's not related to the version of Varnish. It is syntax version 4.1. That's the latest and greatest at this point. And you also need to say where you want to connect to. So in this case, it is on the same machine. We're not yet in Kubernetes land. It's on the same machine on port 8080. This exposes itself on port 80. And we're hooking into backend response, meaning we got a response back from the origin, so we needed to connect to the origin. And we were checking its HTTP response header, and there is a response header called content type. So if the content type starts with image or video and then a slash, what type of content do we have? An image or video, right? Pretty straightforward. So it could be an MPEG-4 video, could be a JPEG, could be whatever. It's static. So what we're going to do is we're going to override whatever was sent via the cache control header and cache it for a year. So it's just as high as possible. And Google likes this, by the way. If you check with Lighthouse, they like you to set for static data pretty long cache control headers. So we forward that to the browser, and the browser can do whatever it wants. So these are just examples. You can use cookies to your benefit. Cookies are a bit controversial in Varnish because Varnish doesn't cache out of the box when it sees a cookie. Because cookies infer or refer rather to highly personalized content. Could be a session ID. I've seen pretty bad cases where someone's tax filings were cached. And everyone logging into the tax system saw that guy's tax filing. So not really ideal. Hence, the out-of-the-box behavior when we see cookies, we don't cache. So in this case, we can parse cookies and strip off all cookies and set the session ID and the PHP session ID, for example, if we see that, and so on and so forth. We can even use language cookies for multilingual content. Let's say you have a page that has multiple languages and you're not leveraging the accept language header. You can use the language cookie and create a cache variation. So for every language that you support, in my case, I don't want infinite variations. The languages that I speak are Dutch, German, English, and French. So if you support those, you create a variation. Or if you use the real accept language headers, just set this header and you're good to go. Let's switch. Let's shift gears. Another feature I really love about Varnish and that I would encourage you to use are edge side includes. Who's heard of edge side includes, ESI, before? Oh, good. I speak at developer conference a lot. Sometimes I have a couple of people know about it. This is an edge site include, an ESI tag. It is somewhat official. It's part of the W3C standard. It was invented by one of the CDN vendors. And what it does is, who's old enough to remember server-side includes from back in the day? We have some veterans of the game here, okay? It's pretty much that, but it's not being parsed on the server, it's being parsed on the edge. So you can include this in your code, and we'll respect it. We'll figure it out, and we'll say, hey, there's a header reference here. We're going to pull that in as a sub request and store that separately. And that way, I'll show you an example here. Maybe I have a perfectly cacheable page, but the header, well, we don't want to cache the header because the header has my name in it based on a cookie, and we don't want to cache my name when Frank goes on the website, right? He wants to see, hi, welcome Frank, and not welcome Thijs. So we could have a separate endpoint there, /header, and don't cache that, and make the rest cacheable. So that means instead of saying the entire page is not cacheable, you say that snippet is not cacheable. Or you compute it on the edge. So it's placeholder technology parsed by Varnish, and you can make the output a composition of blocks, where each block has its own state and its own TTL. And you
Sounds very much like how React does it, right?
Yeah, but let's stop. Yeah, like React, just like React is the source of truth. I have a feeling that we're trying things and say, hey, I have this new thing, and React does this, and then you go back and we've done this a million years before. Now, I'm also prone to that. Maybe I'm thinking, hey, this is great, and someone way more senior than I has done this in the 70s, the 80s, the 90s, who knows? But it is a topic in the developer world that people say, they're trying such crazy things in JavaScript framework, like we're doing server rendering. Yeah, I come from the PHP world. We've been doing server rendering from the early 2000s. So yes, you hit a soft spot there in me. I apologize. It's like, yes, it is like how they do it in the JavaScript world. But what we're doing here to make sure that you don't parse ESI tags always is you negotiate. You can let the server know via this request header that you have certain surrogate capabilities like ESI parsing. And as a application, you can then say, hey, you know what? If I'm sitting behind something that supports ESI, I might as well take control. And that way we know what to do. So that's the beginning. That's the Varnish bit. Let's move into the world of Kubernetes eventually. Because our statement here is that you can run Varnish anywhere you want, on any type of commercial off-the-shelf hardware in the cloud. Docker, cloud native, you name it. If it runs Linux, we are happy. And yes, we have an official Docker image, which is the baseline, of course. Without any container, it's tough to orchestrate in there. Yes, it has been downloaded more than 10 million times, and it comes in 2 flavors. There's a fresh flavor and a
Fresh Alpine.
And a stable flavor. So you can do Docker pull Varnish latest, and it will get a fresh cut of Varnish, which is released twice a year, March 15th, September 15th. This is an open source version, fully managed by the community. We give it backing, we give it engineering resources, we give it funding, but it lives on its own. We have no say over it. So every time, come March 15th, September 15th, I'm curious to see what's going on. I keep tabs on our developers, but they have sovereignty there. Of course, if you want something that is managed by us, there's an open source version called Tag Stable, and that is 6.0 LTS. It's a long-term supported version. We do the backports, we do the security updates. That's our gift to the open source community. And you can run it pretty easily. You can mount the VCL file. You saw the VCL code in the container at the etc Varnish default VCL path. That's a read-only file. And you can mount the execution folder where the magic happens into tempfs. And you can name it, and you can expose ports. You can set the size of the cache. You can do all that kind of stuff.
If I change the VCL file, how does it know it's changed? Does it update automatically?
No, it does not update automatically.
So you have to restart the thing.
Not necessarily. You can even, if you want to log in and call the Varnish reload command, there's even a CLI that you can expose. I haven't exposed that port, but you can remotely connect to it, put the VCL in, reload it without even restarting. Because if you restart, you empty your cache.
Yeah.
Don't want to do that. You don't want to do that. The fun thing is, my colleague Guillaume, a French guy who operates out of the US, made this a bit more valuable. So if you run it using our open source Docker image, there's a set of modules you have in VCL that extend the language. He packaged some extra ones, some red ones. If you were an individual Varnish user installing it on a stock Linux operating system, the red ones you should compile from source. He was gracious enough to add that to our build pipeline. Now, we also have changes coming up really, really soon. where these individual ones will become packageable as well in dep and RPM packages for your convenience. But we all know this, running Docker, a bunch of Docker services on a system in a wonderful world of microservices, it gets tedious, right? It's a lot of work. So we need level of orchestration. And this is where we finally landed the plane and entered the world of Kubernetes. Yes, we're active in Kubernetes. And we think we have a strong position. We can put our stuff in, run it in a container, deploy it to a pod, and offload a lot of the pressure from the systems behind the scene. So you can use it to offload individual pods, individual projects you have. You can set it up more to the front and handle everything behind. And even on super high scale systems, like several hundred gigabit per second systems, we sometimes put bare metal in front of the Kubernetes nodes and offload it there. It depends on what you need, what you have. And we have a Kubernetes spec for it. It's verbose. Let's call it that. It's verbose. It does a lot of things. You don't need to read it. Just remember it's verbose. So how has the Kubernetes community solved that issue of these very verbose YAML files? Helm charts. And that was the thing I had to wait for before I could actually talk about it. We've been having Helm charts for enterprise for a while now. They're very stable. And I asked one of our engineers who operates out of Tokyo to say, hey, can we take that enterprise Helm chart, water it down to the features we have in open source and release it? And he did that 2 weeks ago. So that's good. So you can go, it's an official Helm chart by us. You can go to the Artifact, what's the name again? Artifact Hub.io. You can look for Varnish and you will find our official Helm chart. And you can do Helm, install, set of values file, use that, be ready to roll in seconds. And yes, there's a lot of config.
Oh my God.
A lot of config. But you don't need all of it. We give you the liberty of configuring everything in values.yaml. Here's the minimal one. Is that more manageable for you? So the minimal one is a VCL config. There's also a VCL file property, but then the VCL file needs to be on the cluster. But you can find tricks to push this in. What this does, it doesn't even connect to any pod. It just returns 200 every time, just for the fun of things. But we'll connect something to it. And then, of course, you need a service. As explained in the previous presentation, there's different kinds of service. We recommend initially node port, because I don't recommend that you put a Varnish in front of every single service unless you want something uniquely controlled. My advice would be do it, bind it to node ports or something, put Varnishes on every worker node, and offload all the pressure from everything you have on the cluster. That's my advice. So we have that lined up, and port 80, which is the HTTP port, will be bound to 380, and that will work. And when we deploy it, well, this is what happens. Initially, we see the service that is bound to port 380, so you can do a curl on the system and be ready. But I want to highlight something else that might stand out. Ready 2 of 2. Huh? Why 2 containers, you may ask yourself? Well, the reality is we have a sidecar in there as well. So this is our main one. So if you talk about the responsibilities of the container, our goal is to run the Varnish D service with all the parameters that we need. This is all tunable. This is when you want to Varnish to scale, this is the only thing you really want to do is tweak the thread pools. We can do 1.3 terabits per second on Varnish Enterprise. We can handle more than 100,000 concurrent requests with sub-millisecond latency if you give the system enough network resources, a little bit of RAM, and tune the hell out of those thread pools. But of course, if you want to see logging, that's where the sidecar comes in. We have this binary called Varnish NCSA, and NCSA is actually the format that most web servers use. This is an NCSA format. So you could actually do kubectl logs, contact that container, and see all the traffic come through. Right, let's do something, I would say real, but it's not real. It's just hello world stuff, but let's connect Varnish to something in a Kubernetes cluster. So you can add those Helm repos and actually deploy them. I want to deploy 2 just for the fun of it. Deploy an echo server that just outputs random stuff, and a hello world server that just does that, right? I just copied the commands of, like, I know -n default, it might not be required. I just copied it of their documentation page to make it look sensible. And then we can change the VCL file and actually define the 2 services that we're going to connect to and cache and offload. I would recommend that you use the hostname. There is a supposed caveat. Varnish, out of performance reasons, only does the DNS resolution once. And that is when you compile the VCL code. It does the DNS resolution And for the rest, whatever was resolved in terms of IP, it will use. So if you're in a dynamic environment like Kubernetes, that can pose an issue. But I figured out that if you use these services, these IPs will always be the same. It's what sits behind in terms of the pods that will change. Kubernetes does that mapping. Our engineers told me the only way this does not work is you have headless services. That's what they said. However, I haven't tested this yet, but there's also a dynamic module in there that does dynamic DNS on the fly, so you can use that. So what I'm doing then is mapping it. I'm doing something that looks very ingressy, doesn't it, right? If the request URL is hello, well then use the hello backend, send it to that service, which is probably linked to a bunch of pods. And in all other circumstances, use the ecosystem. And everything is exposed over port 380. And you're good to go. This is what the VCL file would look like, color-coded, more readable, right? So we define the backend to connect to the services. And then that's how that operates, right? Port 3080. What I want to do is show you that there's also an opportunity if we consider that Varnish should live at the front. Maybe configure it as a daemon set. And then it will be removed from your replica sets. It will live as a daemon set. And my cluster, just like the previous speaker, has 2 nodes, not 3. That was a bit cheapish. 2 is good enough. It's good. And then you can see how the multiple pods being scheduled to the multiple servers. All done over plain HTTP. So you may ask yourself the question, what about TLS, guys? Hey, we live in a TLS world. Why no TLS? Here's I wouldn't call it the embarrassing part, because this is part of decisions that the community makes. Up until this very point, Varnish Cache, not Varnish Enterprise, I want to keep Cynthia happy, Varnish Cache does not support TLS natively. That's because the project lead doesn't want to mix the crypto bit with caching bit. From a performance point of view, he wants that to be offloaded elsewhere, and also from a security point of view. If there would be an issue with whatever TLS library you're using, he doesn't want sensitive data that might end up in the cache being exposed. However, after it was started in 2005, we've reached a point where the founder of this open source project says, I'm willing to listen. So we're in the process of doing that there. That doesn't mean we don't support TLS. We do support TLS. However, within the current version of the Helm chart, I would say if you need TLS, use Ingress or use a load balancer that can handle the TLS. That's my initial point. And then you can do a curl of that based on this value, right? Based on this Ingress type, which is pretty straightforward. And then you'll get a fake TLS certificate. But you know how to add your own TLS certificates, right? You can do that. It works. I'm connecting over HTTPS. Wonderful. Going forward, because I'm almost running. No, I have 35 minutes. I still have 7 minutes to talk to you. Wonderful. Still have 11 slides, so that should work, right? What we have, so I said we don't support TLS natively. We do have a TLS proxy that we've developed ourselves that is perfectly open source, that is packaged. You can install it wherever you want. And that's Hitch. And Hitch is a pure TLS proxy, has no awareness of HTTP, and can be used for other things that have TLS as well. I'm also here to say that Varnish Enterprise does support TLS natively at really high pace at 1.3 terabits per second on a single machine. Life is good there. But if we would use our enterprise Helm chart, we could just enable TLS, which would enable TLS within the container and expose the HTTPS port on 30443, and that would have the same effect. Which brings me shortly, I'm going to do this. I'm going to do this from a technological point of view, not from a sales point of view. Explain to you what certain capabilities we have in Varnish Enterprise that might be useful. So yes, we have native TLS both at the front and at the back. And the native TLS at the front is also mutual TLS. So as a server, you can also validate your client and vice versa. We have something called the massive storage engine, which I could talk about for an hour in itself. Let's just call it an extension of your memory on disk without the slowdown, without the disk fragmentation. It operates on pre-allocated large files with file system like behavior on the inside, asynchronous direct I/O, and an override of the Linux page cache, so that we are more opinionated to do this a lot faster. That's, I would say, our main selling feature. People love this. We have dynamic backends, so we can do DNS on the fly. We have a control plane and routing device. We can actually build your own CDN using all of that, purely software-based at super high scale. And some of the bigger companies on our planet who are clients of us, various verticals, do that. We have a pretty large collection of vMods, those modules that you saw in the list that extend the language, that could talk to all types of systems. So clients come to us and say, we want to interact with this system on the edge. We don't want to do it at the origin. We want to do it on the edge. And we built the module for them. So that's the collection, and so on and so forth. I just want to present the technology. If you're at Broadcast Stage and want to hear about it, want to see a demo, this is not the place right now. This is Kubernetes Meetup. Come see us there or reach out afterwards. Now I want to talk about the future, and that's the last thing I want to do. I managed to convince an engineer of ours to build a very stable version of the Helm chart, but it's a V1. I see potential for a V2, V3, V4, you name it. So if you look at the future of us as a project and as a company in terms of the cloud native ecosystem, I would say we need to improve the Helm chart a bit. Initially with documentation, it's undocumented. I just wanted to have it. So when I come here, you can do Helm install and try it yourself. I want to publish these slides, so if you want to see some of the commands later, play along with it yourself, that's fine. I'll tweet about it, probably end up on LinkedIn as well. But I also want to have better TLS handling in Varnish Cache, because you've seen it that we have our Varnish D runtime, we have our sidecar for logging. Why don't we have a sidecar where that Hitch product or project that I talked about is it? Shouldn't be that hard. Now, of course, our engineers have a lot of work, but when I get home from this trip, I'm flying back tomorrow, I will reach out to my colleague in Japan and ask him to maybe consider building a sidecar. It shouldn't be a lot of work. You guys know how Kubernetes works. You know how to set it up. It's just an extension of the container definition. Add a container, expose the service, make sure you can mount certificates and that kind of stuff. So that's that. But also I've presented it as a daemon set with node ports positioned at the front. We will also, I'm looking right at our CTO here who helps decide on the roadmap. We should have an ingress controller, because what we do is ingressy. I know, 5 minutes. I see it here. To be exact, it's 2 minutes and a half. 2.5. So since we position ourselves at the front, and since my advice is to offload the pressure on all those pods you have more at the front than for any individual service, there is a specification for ingress, and we could do ingress pretty well. It's just a matter of positioning ourselves there, not just as a router to route traffic over HTTP to the right services, but also to have like be a first-class citizen in the Kubernetes ecosystem as a cache, so that you can use not necessarily VCL, but also the specification and the annotations to say, I want to cache this, I want to cache this for so long, I want this to be bypassed, I want to handle these cookies. That's something I want to do. Auto-scaling in our control plane would be nice, and also that's something we're working on. We're working on a WebAssembly runtime in the open, so that you can actually run inside a Varnish container on the edge, potentially within Kubernetes, run WASM workloads. So have any of your code that typically runs at the origin, compile it into the bytecode of WebAssembly and run it in our engine, either individual functions or entire programs. So the future looks bright. We just want to be a good citizen of this community, of this ecosystem. So I would advise you to go to these resources. If you want to learn about our open source Docker image, it's on the Docker Hub. If you want to see the source of how we do it, you can go to GitHub. You'll find the different flavors, see how we compile it, see how it works, also see how we package the modules. If you want to play around with the Helm chart, you can find it there. These slides will be online, so you can run the Helm commands yourself. And if you want to learn about our enterprise Helm chart, which goes a bit beyond that, whose configuration is even longer and has more options, just go there. And that being said, ladies and gentlemen, in this lovely place called Singapore, where it's hotter hottest, thank you very much. I still have books to raffle. I think we've reached the end of the formal session. Thank you for that. I really enjoyed it. It's always nice when you can say to your friends, hey, tell us what we're doing. Yeah, I was hanging out in Singapore doing talks there. It's kind of cool. So thank you for that. Thank you for giving me that. I am not arrogant enough to think that everyone wants my books.
We need to call Ritesh.
Okay?
Yeah.
We need to call it that. Oh, I'm out of order.
You want to do a game kind of thing.
Okay.
Oh, wonderful. You just give.
I can give them away?
Yeah.
Okay, let me get back to my pitch. I'm not arrogant enough to think that everyone is interested in these books. I'm not like that. The typical way I do it is let nature deal with it itself. So I'm going to put 2 books here, right here.
Evolution.
I'm going to walk away. I'm going to leave them there. And if no one picks them up, they belong to Microsoft. However, I am arrogant enough to, or friendly enough maybe, to sign them if you want. That being said, thank you. It's been a great honor to be here. It's been an absolute pleasure. See you next year.
Thank you, Jeff. Thank you very much for such a wonderful session. Yeah.
There are questions. I usually dodge the Q&A, but since we're here,
It's a curiosity. So, because we do a lot of MTLS within this thing, so we have a service mesh like a Linkerd or
Yeah.
So let's put this out and obviously.
I'm Hans Stay screen everywhere, so find me and challenge me, figure it out. And if I can't answer, we have to have people in the office.
I've got 4 nasty letters for you.
Yeah?
I've got 4 nasty letters for you.
4?
Nasty letters.
Yeah?
gRPC.
Yeah, well, we do HTTP.
Yeah.
HTTP.
That's
But it's an interesting concept because we're not alone in the ecosystem, right? If we position ourselves in a proper way and do the service meshing thing and handle the TLS, we should not be.
The communication and cannot happen without the service mesh. So my thoughts, even though if I like it or not like it, it needs to be residing controlled by the service mesh, and that's MTLS.
Yeah.
But other services not MTLS.
I need to definitely update it.
Okay,
No.
well, MTLS, right? Mutual TLS, right? Well, our TLS proxies support mutual TLS. Within the cluster, so the cluster would communicate with our pods, right? And since we support multiple TLS, the cluster would do an MTLS request with our TLS.
Backend server partners which have a server backend, right? And I've deployed an MTLS and a service mesh. So any other service that needs to be also needs to mesh by the same service mesh. Otherwise,
Well, I think we need to talk about this separately. I understand where you're heading to, but the specifics are the specifics. So let's do this off bat and try to figure out a solution. All right, I think that's my cue to say goodbye. Thank you very much.
Thank you so much. So next is the feedback. Please scan and then give your feedback. Yeah, please feel free to give your inputs.
Did my laptop end up somewhere? Where's the laptop?
It's there.
Okay. I need that.
So you said might not work with gRPC, right?
It will just.
Isn't gRPC on protocol over HTTP?
Please give us the feedback.
We don't know fix the gRPC.
First, we will get code plus description.
But the whole is still resting.
So much. We have 5 goodie.
Okay, 5.
There you go.
And then this one.
And we will get code cloud subscription for 6 months.
Okay, is it done? Yeah. So if you're done with the feedback,
I'll have to think about it. Let me think about it. Sorry, I'm very zero.
it's a quiz time. How did yeah. How do you join? That's how I do.
I'm pretty anxious.
Start quiz.
So
Before introduce what all books we are going to tell that first.
Okay, so it is for both online and then who are presented here. We have 10 questions, and first 3 winners will get a Code Cloud 6 months subscription, and then maybe another 5 we have a goodie bags from Varnish. Okay, so let me put the QR code to subscribe, right?
Where do
What is it? You need to subscribe. Create a Okay, so create your account and ensure house a name and then the same mail ID which is registered as for the event.
So total 8 winners. First 3 will get Code Cloud subscription for 6 months, and remaining 5 will get goodies bag from Varnish. It's special curated goodie bags. Has lots of things in it.
Email address, right?
Oh yeah, your name and then mail ID should be matched to the
The
one
one is
registered for the
registered for the
event or the session. Are you ready? Can you move on? Okay, thank you.
How many join? 37, 39, okay, 40. 40. They're joining. They're joining.
Yeah, I think here 40 plus.
Yeah, I think 40. 40 is constant now.
So you can't wait.
Open in the 3 browser.
Okay, are we good to go? Okay.
check your screen. Your mobile screen.
Yeah, your mobile screen.
It will come up.
In second, what is the name of Varnish built-in programming language? Varnish configuration language, Varnish built-in C language, Varnish flow control language, Varnish caching language. Caching language. Okay,
Oh, configuration.
29 participants. So div, who is div?
Configuration.
And then next.
Click on leader one. You see the leader.
Okay, so which of the following cache control headers forces system not to cache? Cache control, no cache.
Yeah, good one.
Cache control private. Cache control no store. Cache control dot cache.
The Singapore version is don't cache.
Oh, okay. 16 participants. Again, div is leading. And gates. Okay, next question. Ready for next question? What is the name of open source TLS proxy that is part of Varnish ecosystem? Pound, Nginx, Varnish TLS proxy, Hitch. Quick.
Some sort of dog.
Okay, good. Hitch. Again, still Div is leading.
He wants Code Cloud subscription.
So remember, we have 3 Code Cloud subscription for those first 3 winners. Okay, what does ESI stands for? Element Service Inclusion or Edge Speed Introspection, Edge Side Include, Effective Server Inclusion.
I came up with all these questions at the pool in Sentosa.
Okay, that's good. 23 participants.
Cyril is at the top.
Oh, okay.
Uh-oh. They screwed up.
But still, Dev is leading. And what is the name of sidecar container that runs alongside the main container in Varnish? Varnish CNAS, Varnish ACS, AC, Varnish NSCA.
NCAC.
Okay.
Good stuff.
Still good. Dave is leading now.
He's back, he's back. Who did?
How can you expose your application to the internet in AKS? Use a load balancer service type, use node port service type, use ingress controller. Okay. Next question. Okay, so which of the following is the first step in deploying containerized application app to AKS? What is the basic requirement to deploy an application?
Yeah, I guess that is, I guess, yeah. You know,
Okay, that's good.
Yes.
Last question.
Okay, last question. Okay, how can you enable auto scaling for your application in AKS? Configure HPA based on CPU and memory. Use Azure CLI manual scale the number of
Disagree, disagree. Wrong.
Controversy.
Even right. If my nodes are in the public subnet, then I can expose it while looking at, right?
Okay, so here is the ladder board.
HPA.
Yeah, leaderboard. We have Dave.
There it is.
Yeah, it is ended.
Come forward. Okay.
So first three participants will get a
First three participants, can you come? Yeah, Dev, Cyril, and Natran. Nath. Okay, we'll take a photo.
And you guys give your email address to.
Yeah.
Okay, congratulations.
Don't worry, there are some client options. You guys can collect it later. Okay. Now I would like to call remaining 5 of them. Lee Ing Yang,